Hi everyone, Matt here, and this is an advanced beginner R programming tutorial where I'm going to show you how to forecast past and future NCAA football games using logistic and linear regression to forecast both spread and win probability. So what differentiates this tutorial from a lot of other tutorials that I've seen out there is that we are going to be connecting to a data set that I have set up to update every week to bring in the latest and greatest data, because a lot of the tutorials or code out there that I see is looking at static data, because a lot of the data sets that are updating sort of dynamically or every week are you have to pay for those, so there's not a lot out there. So I'm going to be offering this for free. I have a script that scrapes the data automatically, and I'm hosting this data on GitHub. So with that said, remember to subscribe below, because I'm going to be updating, I'm going to be making updates to this model. I'm going to be putting out some other content and some other free data sets, hopefully with some NFL data and a lot of the other major sports. We're hopefully going to cover some political data, some economic data, and some stock market data as well. So remember to subscribe below. Follow me on Twitter, because as I am making changes to these data sets, I'm going to be posting those changes there. And so if you are relying on one of these data feeds, you're going to want to know when things change. So with that said, let's dive right into it. So the first thing we're going to do is we're going to go into our RStudio session, and let's import two packages. We'll import the dplyr package, and we'll import the readr packages. These are actually the only two packages that we're going to need for this tutorial. So this is going to be pretty straightforward, and I'll get into what each of these are doing. But just real quick, dplyr is part of RStudio's Tidyverse suite of packages, and it's very good for manipulating and cleaning data. So if you're not familiar with this package or the Tidyverse in general, I would highly recommend heading over to my channel and looking up my video on basic data manipulation in R, or I'm also going to link below to DataCamp, which is a paid tutorial service, but they have a lot of great videos and tutorials on R, on Python, and definitely on the Tidyverse. So that's probably the number one best place to go if you're looking to get more information on the Tidyverse. Otherwise, if you're just looking for like a quick reminder, my video on basic data manipulation should do just fine. And then so the second package we're going to load is readr, which is pretty straightforward, and it's just going to help us read in the data feed. So to get started, let's create a variable called NCAA L1, and we're going to use the read_CSV function. And then to get the actual data itself, what we're going to have to do is head over to my GitHub account. And if you go to open data, so my GitHub username is mattc137, so head over to that, click on open data, go to data, sports, NCAA football, and here you'll see two data sets, one for NCAA level 1 and one for NCAA teams. So the level 1 data is all I have scraped right now. It is basically the high level like wins and losses for each team. And so if you click on this link and hit view raw, that will actually let you view the CSV itself, and it'll also give you this handy URL, which we are going to copy, and we are going to bring that into our R session by pasting it in this read CSV function. So if we execute this line, we can now see that we have over 52,000 observations and 15 variables. If we click this open, we can see the data itself. So you'll notice that the first line here is, actually let me shrink my screen here a little bit. So you notice the first line here is a game that was on October 31st, Florida Atlantic versus UT San Antonio, and now we just have a bunch of metadata around the game. So this was a win for Florida Atlantic. They scored 24 points, and UT San Antonio scored 3 for a spread of 21 points. This game was in fact played. This is an important variable because there's also a bunch of future games in this data set, so those are going to be games that have not yet been played. And that's going to be how we're going to separate this data set, and we're going to have a list of upcoming games that we can apply these forecasts to. We have a dummy variable for whether they're home or away, and then the other important variable I'm going to point out is this game ID. So you'll notice here that each game is listed twice because I want each team for each game to have one entry as the team, so in this team variable. So in this first entry, I have Florida Atlantic as the team, so the result applies to Florida Atlantic, the points for applies to Florida Atlantic, the points against apply to the opponent, and the spread applies to Florida Atlantic. So it's going to be Florida Atlantic's score minus the opponent's score, which is UT San Antonio. And then the next line item you'll notice is the exact opposite. So here UT San Antonio is sort of the team of focus, where now Florida Atlantic is the opposing team. So the result applies again to the team, so it applies to UT San Antonio, and everything you'll notice like points wise and spread wise is the opposite. So like home field advantage is opposite, and you'll notice that the game ID for these is exactly the same. So jumping back here, I'll also make note that all we're doing with the readr is we're importing this read_CSV. BaseR has a read.csv function, but what this does is read.csv is just going to import everything as a string. So read_CSV is going to try to guess at what the variable is. So you can see down here it's making guesses. So season it's saying is a double, team is character, so forth and so on. So points for these are doubles or numeric, and so that just makes it easier, so we have to do less cleaning. So the next data set that we're going to bring in is the NCAA teams list. And so to do this, we are going to head back to the GitHub account, and back in NCAA we're going to go to the teams list, and we're going to do the same thing. So we're going to click the raw data view, we're going to copy this out, and then we are going to paste it into a read_CSV function. And then that is going to give us our list of NCAA teams. So you can see here's a list of over 500 teams, and we just have one dummy variable, FBS, which is determining if it's a Division I team or not. So it's a 1 if it's the highest division, and it's a 0 if it's not. And so let's keep going here. So then the next thing we're going to do is we're going to clean up these data sets just a little bit to prep them for the analysis that we're about to run. So I'm just going to set up a new comment here. And what we're going to do is we're going to start with the level 1 data set. And I don't know if I mentioned this earlier, but I'm calling it the level 1 data set because it's only the high level information about each game, right? So we're not looking at team stats, we're not looking at individual stats, it's just basically win, loss, and points. And then some metadata around the game itself. So that's what I mean when I'm saying level 1 data. In the future, there'll be level 2 data, which is going to have the high-level team stats, and then level 3 data, which is going to have the player-specific stats. So again, remember to subscribe so you can get those updates as I am releasing that data set. So to start, we're going to add some columns to the level 1 data. So to do that, we are going to say NCAA level 1. We're going to use a mutate function. And you'll notice I use the piping function here, right? So this is covered in my basic data manipulation video, but I'll go over it very briefly here. So if you hit Ctrl-Shift-M, that's going to give you this pipe. And basically what's happening is anything to the left of the pipe is going to be the first argument into whatever is right of the pipe. So it will basically look like this if we were to not use the piping function, and then whatever arguments are to come would be sitting within the mutate function. So let's actually undo that. And what the mutate function is doing is it's actually creating columns within our data set, and so we'll see how that's working in just a second. So First, we need to come up with our ranking system, and we're going to use an ELO ranking system, which is what chess uses. It's basically just looking at the wins and losses, and then it's evaluating and updating rankings based off of your opponent's strength, basically. So if you beat an opponent who has a much lower ranking than you, a much lower ELO ranking than you, your ranking is not going to change much because it's expected that you're going to win that game. But if you have two teams play and there's a big upset, so you have a wide spread between the two teams' rankings, and the team with a lower ranking wins, they're going to get a big boost into their ranking, and the team that lost is going to get a big knock on their ranking. And so over time, this kind of plays out, and as we'll be able to see, you can get a pretty accurate ranking system just based off of this methodology. So I'm going to continue going forward, filling this out. So we're going to have ELO, we're going to have the opponent's ELO equals 0. We're just going to initialize these to 0. We're going to clean up the results field. So right now they're WLRT based off of the result, but we want those to be numeric. I could probably use a case 1 here, but I'm just going to use if-else statements to clean these up. So if it's a win, 1. If it is a loss, 0. If it is a tie, we will say 0.5. And then just to make sure this is numeric, I'm going to say as numeric result. Okay, and so now if we send this to the console, hit Control Enter, NAs were introduced, that's fine. That's just going to happen every now and then with a huge data set like this, so I'm not going to be too concerned about it. I'll try and diagnose this after the video and clean up the underlying data set, but that shouldn't be too big of a problem. So if we open up the data set, we can see now we have ELO, we have opponent's ELO, and we have result is now a 1 or a 0 rather than a W or an L. And so now we also want to do the same thing. We want to add an ELO to the NCAA teams. So I'm actually just going to copy this down here. And we're going to use our piping function again, a mutate function. We're going to say ELO equals if else FBS equals 1. We're going to set it to 1500 if it is part of the FBS. If not, we're going to set it to 1200. So what we want here is we want to say right off the gate, we know that our Division I teams are starting out as better than our non-FBS teams. So that's all that's saying there, and we're going to add this column to the NCAA teams list. So now you can see we have this column. Everything's initialized to 1500. If it is not part of the FBS, it's initialized to 1200. Okay, and so now what we want to do is we want to split out, as I mentioned before, this data set, the NCAA Level 1 data set, has both played games and games that have not yet been played. So what we want to do is we want to get rid of games that haven't been played yet from our data set for when we're building our ranking system. And we want to separate those out into another data set. So what we're going to do is we're going to say NCAA L1 future, and we're going to say NCAA L1, and what we're going to do is we're going to use a filter function. I'm going to say played equals false. We're also going to say game ID is not canceled, and we're going to put that in quotes. And we're going to say game ID is not postponed. So this is postponed is something, canceled games are something that I'm seeing a lot of in the 2020 season. Just because of COVID. So a lot of stuff's being postponed, a lot of stuff's being canceled. And so we don't want to include those in our future games data set. So once they actually have a future date for them, they won't be canceled or postponed anymore. They'll be back into the data set, and we'll be able to pick those up just like any other future game. So we're going to execute that line, and that should create us a new variable. So NCAA future, and we have 660 observations, so these should all be games in the future. So as of now, today is November 7th, so everything should be after November 7th in this data set. And, right, hopefully you could see that, right? So these are games that are up to 12/12. So let's keep going here, and so now we have a carve out data set for the future games, but now we need to get rid of the future games from our main NCAA level 1 data set. So let's do that. And the way we'll do that is we will filter based off played equals true. And then we're going to want to arrange this data set by date and by game ID. Okay, so now we can see that this is starting in the year 2000, right? And it's going up in order of date, and we can see that the reason we ordered by date was so that this would be in chronological order, and then the reason we ordered by game ID was so that each game would be on top of each other. So we have Florida State, BYU, Florida State, Kansas State, Iowa, Kansas State. So this is, and like I mentioned before, this structure is going to really help us when we create our ranking system. So let's go ahead and let's jump into the ranking system itself. So the first thing we're going to want to do is we're going to want to loop through this NCAA level 1 data set. And so rating system. Okay, so the first thing we're going to do is we're going to create a for loop. So we're going to say I in 1 to n row NCAA level 1. Okay, and what we're going to want to do here is, as we're looping through this data set, we are only going to want to stop and execute some code anytime the row number is odd, right? Because these two games are the same. So when we're creating our ranking system, we can handle them both at the same time. So we're going to have when I is odd, it's going to stop. It's going to bring in the data from from the row that it's on and the next row, and then we're going to update the rankings for both teams at the same time. Let's sort of get going with that, and hopefully you'll be able to see what happens. So the first thing we want to do is we want to prevent any code from being run if the row is odd, or if I is odd. So we're going to use I modulo 2 is not equal to 0. And let's actually just print out I. So if we were to run this real quick, right, you can see that all of the I variables are odd. And so now if we go into the code itself, and we'll actually leave that print function there, so when we're actually running the system, we can see where it is. So the first thing we want to do is we want to load both teams. So I'm going to say team A is, and I really just need to copy out this NCAA level 1 and just keep it on my clipboard because I'm using it all the time. So team I, and now I'm going to copy this. And we're going to say team B is I plus 1. And actually, let's do a dummy variable up here, just I equals 1. And we're going to comment this out, actually. Make sure you comment that out now. But just so I can run this test code without having to run the full loop, I'm just going to have this dummy variable up here so that I is just always equal to 1 while I'm building out this for loop. So let's execute these two lines. Okay, so you can now see that team A is Florida State, team B is BYU, which should correspond, right? So Florida State, BYU, perfect. So the next thing we're going to do is we're going to get the result. And, whoops, okay. So we're going to get the result for team A. result for team B. And every time we're doing it for team B, it's going to be I+1. Right, so we can see that team A won, team B lost. Okay, so the result, and I executed something that overwrote my code here. Oh no, so sorry, I'm in the future. Close out of that and close out of this. Okay, so we can see that, right, we can see that Florida State won this and BYU lost it, which corresponds to result A and result B. So the next thing we're going to do is we're going to bring in the current ELO rating for each team. So to do that, we are going to say ELO A equals as numeric NCAA level 1 teams, and we're going to subset NCAA teams where team equals team A. And the column we want is ELO. So let's execute this. Okay, and so we see 1500 for team A. And let's copy out this line and do it for team B. And let's enter, and now we have 1500. Okay, and so what is happening there is we're going to our NCAA teams list. We're looking up, so we're looking up Florida State, and we're pulling over the ELO. So we're looking up Florida State, and we're grabbing this number, and we're also looking up BYU, and we're grabbing this number, and then we're plugging them into ELO A and ELO B. Okay, and then what we're going to do is we're going to load these ELOs back into the main NCAA level 1 dataset. And so to do that, actually let's make a note here. I'll load current ELO into the main NCAA dataset. And so the way we're going to do that is we are going to subset using I for A, and then we're going to do I+1 for B, +1, and so let's look at our NCAA level 1 data set first. So remember we set ELO to 0. So now we're going to be updating that based off of the number that we pulled down from the teams list. So now we can see we have loaded the ELO for Florida State and BYU. And so we need to do the same thing for the opponent ELO. So we can just copy this out. And then we'll switch B into A. It's the same for this example since this is the first game in our data set, but as we go on and teams have different ELOs, we'll just be flipping the ELO right there. So, and actually, can we, oh, so we have to do op ELO for both of these, so I messed that up. So let's just run this line again. Okay, and now we can see we have ELO and we have the opposing team ELO. So now to update the actual ELO, and I'm just going to run through this pretty quickly here. If you're interested in actually understanding a little bit more about ELO, obviously Wikipedia is a great source, but I'll also put in the description to this video this source here, this Metin's Median Math, they have a good rundown of the steps used to calculate ELO. So I'll link to this in the description in case you are interested. But for now, I am going to type this out so you can see. And so the first thing we are going to do is we need R, which is going to be 10, to the ELO of A divided by 400. And so what this is doing is this is basically scaling the ELO value. And so we're going to do this for A and we're going to do this for B. B, and let's just run this just to make sure. Okay, yep, so we have our newly scaled ELO values here. And then what we're going to do is we're going to create a variable called E for A and B, which is going to take R A divided by R A plus R B. So we're going to copy this out. And we're going to do it also for B. Okay, and so if we execute EA and EB, this is basically the percentage that we're going to take after we determine who wins and the strength of the opponent here. So if we execute both of these, right, since the opponents are exactly evenly matched, we're seeing 50%. So each game is going to have what's called a K value, which determines how much we're going to update each team's ranking afterwards, and then this sort of percentage determines who's getting what breakout of the new points that are being awarded. So now that we have that, we can actually create our ELO updated for A, which is going to be starting with our ELO for A plus 40. This is our K value. So basically the most you can win in a game is 40 points. So 40 ELO points is the highest number you can possibly win, and both teams are basically competing for a percentage of that. Well, a weighted percentage based off of how close they are in terms of ranking. So I would highly recommend reading up on ELO to get kind of a better description, because I think I butchered that a little bit, but hopefully you can see what I'm doing here in the code. So if we execute that, so we can see that since Florida won, they got 50% of this. And so now their new ranking is 1520, and if we run that for BYU, we can, and let me just make sure I've got the right variables here. Okay, so running this for BYU, we can now see, right, so 20 points were awarded to Florida State and 20 were taken away from BYU. And so now we got to get these back into our teams variable, which will update sort of our master list of ELO rankings. So let's go ahead and update that. So we're going to update team ELOs. And to do that, we are going to start with our teams dataset. Actually, we can just copy out, we should be able to copy out this code up here where we initially imported. So right in this line, we imported each team's ELO into ELO A and B. So I'm just going to copy out this inside, what's inside as numeric. And I'm actually just going to paste it down here. And so for A, we're going to do ELO updated A. And then I'm going to copy this. Okay, and now for B, I'm going to do ELO updated B. I'm going to execute both of these. Now if I go back to the teams list, right, so we can see BYU, now their ELO has been updated. And so now when since the NCAA level 1 data set is in chronological order, next time BYU has a game, they're going to import this 1480 number rather than the 1500 number. And that's going to keep continuing until we get to the current week's games. And so let's run this out. This is going to take a few, well, actually it shouldn't take that long to run. So let's run this for loop out and see actually how long it takes to run. So since we have that print function, we can kind of get a sense of how fast this is running. It's actually moving at a pretty decent clip here. So actually, yeah, I'm just gonna let this run, and we're gonna start coding the next sort of section. So the next thing we'll do is once this runs, we kind of want to get a sense for the top 25. So we're gonna do NCAA football L1 teams, and we're gonna filter where FBS equals 1, so that we only have FBS teams, and we're gonna arrange this by descending ELO values and ascending ELO. Okay, and then we are going to take the top N, and in there we're going to put 25. And then so that is going to give us our top 25 once this runs, and it's almost there. So I'll start setting up the next section while, which we're going to look at the naive wins based on ELO. So in this next section, once this runs and we take a look at the top 25, we're going to just see how the rating system itself does in predicting wins and losses. So we're not going to do any machine learning. We're not going to do any regression or logistic regression. We're just going to see historically, was ELO able to predict the winners and losers of games? Because remember, right, what we're doing here is we are importing the ELO for each team before the game itself is played. So this is information that we could know before the game is played. And so what we're going to basically look at is if ELO is greater than the opponent's ELO, that should theoretically be a win. Obviously, there's other factors like whether or not it's a home game. But for our first naive cut at the data, we're just going to look at ELO. Okay, so now this is run. And now let's take a look at our top 25. Okay, so here's our top 25, and this is pretty sensible. So this is the 2020, the 2020 season, and we can see that Alabama, Clemson, Ohio State, these are our top 3, which is a good sign. We can still see LSU in here, which I think is pretty much out of everyone's top 25 at this point. But that's one of the flaws of ELO, is that it takes a little bit of time to update and to work its way through the system, because LSU would have had such a high ranking at the end of last season because they had such a great season that even though they're not having the greatest season this season, they're still up here. So it's taking a little bit of time to update, and that's why we're seeing LSU up here. But otherwise, I'm seeing a lot of names on here that I should be seeing. So Notre Dame, yeah, that's a good sign. So, yep, so that looks pretty good, looks pretty sensible to me. And so let's try and take a look at our naive wins. So what we're going to do here is first we need to do some cleaning of the new data set. So we are going to take our NCAA L1 data set, and we're going to add some columns to this. We're going to mutate. And let's just make sure our ELO, and whenever you're in this mutate function, just be aware when you're assigning variables, you got to use the equal sign. So you can't use the arrow like you can when you're outside of the mutate function. Just a quick note there. So let's make sure these are numeric. So we're going to say ELO, I'm going to say op ELO equals as numeric. Sometimes I cannot type and talk at the same time, so apologies for that. And now we're going to create three new variables in our data set. So the first one is going to be ELO difference, and this is going to just be ELO minus op elo. And then we're going to do elo forecast prediction. And that's going to equal if else. So elo is greater than opponent's elo. And that's going to be 1 or a 0. So basically our forecast right here is just if, and let's take a look at our data set. So if elo is greater than the opponent's elo, oh no. Okay, so I made a small flub up here since I updated this, and then I updated it again when I ran the initial for loop, so I'm not going to really be too concerned about this at the moment, but these should say 1500 for these first 4. They got overwritten again because I was kind of maneuvering inside that for loop, but if you run this script through, these are going to say 1500. But anyway, so basically what we're doing in this simple prediction is we're looking at, let's scroll down and let's get some real numbers. So right in this example, actually let's look at this topic of top row. So this is Wisconsin, Ohio State in 2004, right? And so Wisconsin has a 1600 elo and Ohio State has an 1800 elo. So we would expect that the predictive value in this case, since elo is less than opposing elo, we would expect a loss, and that's what we're plugging in to this elo forecast prediction. And then what we'll do is elo forecast result equals if else elo forecast prediction equals result, then 1 or else 0. So this is evaluating our model. So if the forecasted result was the same as the actual result, it's going to be 1. If not, it's going to be a 0. So we want to know what percentage of these rows are going to be a 1. And so let's actually execute this line. And so again, if we open up this data set and let's look at more current games. So, okay, so we're going to look at Florida Atlantic, UT San Antonio, right? So Florida State had a higher ELO, right, than UT San Antonio, right? So there was a 220 ELO difference. So on this basic naive model, we would have forecasted that Florida State was going to win, and they did win. So that's a good sign, and we're going to calculate what percentage of the ELO forecast results we got right. So to do that, we are going to, actually, let's just look in 2019. So let's say results 2019 equals NCAA L1 filter season equals 2019. And now what we can do is we can sum the results. Oh, and I said 2019. So we can say results 2019 of ELO forecast results. So we're going to sum up all of those results, and then we're going to divide it by the number of rows and results 2019. Okay, and we can see that 72% of the games, just based off of this simple metric, are being predicted accurately, which is pretty freaking awesome, just given the simplicity of the ELO ranking. So once we get into the level 2 data where we're looking at statistics of the teams, and level 3 data where we're looking at player stats, and maybe even some drive stats, I think we can really improve upon this number. But let's keep going from there. So let's actually forecast the spread using some linear regression. So here we're actually going to use some basic machine learning to forecast the spread. And so the way we're going to do that is we're going to call our model spread LM, and I'm going to call it spread LM1 because a lot of times when I'm building models, right, I'm trying a lot of different models, and so I just want to keep track of which one's which. I should probably have something better than a numeric system. We're not going to do more than one in this video, but this is just habit. So, so we're going to use the LM function, which is basically the linear model, or it's what's going to give us a linear regression. And so the way we're going to forecast the spread is we're going to use the spread variable, and we're going to use the tilde, which means we're going to regress. We're going to forecast the spread model given the ELO difference and given the status of whether it's home or away, because obviously in football there's a significant home field advantage. And the data set we're going to use is the NCAA level 1. And we're going to actually filter for seasons that are greater than 2013 and for seasons that are less than or equal to 2018. And so the reason I'm doing this is because as you saw in the data set already, the rankings for the year 2000 are pretty much irrelevant just because everyone's starting at 1500. So it takes the model a little bit of time to kind of calibrate and make some sensible rankings. So I'm going to take 2013 to 2018 just as sort of the sample set to build to train this model. And the reason I'm not taking up to 2019 is because I want to test out how this model is doing on the 2019 data. So I don't want to build the model with data that I'm going to be testing the model out on. This is very bad data validation, by the way, but for this video, I think we're going to keep it simple, and I don't think we're going to do too much in terms of validating these models. And so to basically predict all of the games within the data set, what we're going to do is we're going to create a new column in the level 1 data set called spread prediction LM1, and we're going to use the predict function. The first argument is our model, and then we're going to use a new data argument, and that's going to be the whole data set, the whole level 1 data set. And so now if we execute that, whoops, and I didn't run the model to begin with. So first run the model itself, and then we're going to predict the spread data. And so now if we open up the level 1 data and we sort it, we should be able to see that we have spread predictions based off of the ELO difference and based off of whether it's a home game or not. Okay, so for this game, we predict it. So this first game up here, which is Florida Atlantic, UT San Antonio. And what we predicted was that the spread was going to be plus 15, right, for Florida Atlantic. And what actually happened was the spread was 21. So a little bit off, but still, I mean, reasonably within the ballpark of that spread. So I would say that's a reasonably okay prediction for given the simplicity of this model. And so let's see how this would have done in 2019. So and the way we're going to do that is we're going to say results 2019. And actually, we can pretty much just copy this line from above. And what we want to do is replace the new data with the results 2019. And now we can kind of take a look. Actually, let's leave this for now. Let's take a look after we do the game forecast. So let's not evaluate how our spread did on 2019. Let's keep moving, and we'll build another model to forecast the win probability, and then we'll take a look at how we did in 2019. So this is going to be win probability, and we're going to use logistic regression for this model. And for those of you who aren't familiar, logistic regression, what we're going to be doing is we're going to be looking at forecasting a variable with two possible outcomes. So in this case, the possible outcomes are a 1 or a 0 based off of win or loss. And then what we'll be doing is we will be calculating a probability of the 1 or the 0 coming out in the data. So what we're going to do is do win probability GLM, let's lowercase this, GLM 1. And instead of the LM, we're going to use GLM for, I believe it's general linear model, I think is what that stands for. And again, so we're going to take a similar model to up here. And actually, I can probably copy the inside of this out of the linear model into the general model. And so inside, we're not forecasting the spread anymore. We're forecasting the result. And we're going to still keep ELO difference. We're still going to keep home. The data is still going to be 2013 to 2018. But the one thing we want to do is after our model here, so after results tilde ELO plus home, we're going to add a variable called family equals binomial. So this is so that it knows that it's a binary variable that we're trying to forecast. And so let's run that. And then, so what we're going to do is we're going to say, actually, let's just copy this out. Actually, let's copy both of these lines out so that we can predict the win probability given our data set. Okay, so right now, what we're looking at is we're going to flip this model out for the original model, and we are going to flip the name of the variable within each of these data sets. So if we run these out, and actually we actually need one more variable in the predict function for when we're using the logistic regression. We actually need type equals response. So this is what's going to actually ensure that we get a percentage. Oops. And so let's run those. Okay, so now if we take a look and see how we did in 2019. Actually, let's take a quick look at the data set first. Right, so now we have our spread prediction, we have our win probability, and you can see that for each game that we've predicted in the data set. So now let's evaluate 2019. Again, usually you're going to be taking a little more caution in validating your models, but here we're just going to kind of be a little relaxed in our validation, just to kind of see what's going on. So I already predicted this for 2019. So what we want to do is we want the win probability GLM. What we're going to do is within our data set, if the win probability is above 0.5, we're going to say the forecast is to win. If it's below, the forecast is to lose. So to do that, we're going to do if else results 2019 spread. Not spread. We want our we want our forecast, or no, we want our win probability. If it is greater than 0.5, we'll say win, else we'll say loss. Okay, so I had some extra parentheses, it would seem, in this statement. So now if we take a look at this, for 2019, sorry, we were in 2019. Right, so now instead of the probability, we just have a 1 or a 0, and now we can kind of see whether or not that foots to the actual results. So, and the way we'll do that is we are going to say sum of results 2019 win probability GLM equals results 2019 result. Oops. Result. And then we're going to divide that by the number of rows in the data set. Execute that, and you see now we have a 73% win rate looking at the logistic regression model, where really the only difference between this is that we added the home variable. So we got a little bit of a boost from adding that home variable, but nothing too exciting there. But, you know, I mean, 1% is 1%, so we'll take it. I think the importance is kind of understanding and seeing how these models come together. So in future videos, we're going to really focus on getting this up. But for now, I think that's good enough. And so now what we want to do, though, is we want to be able to forecast next week's results. Or this week, or the upcoming week, however you want to kind of describe it. And so the way we're going to do that is we're going to start, we already created the NCAA future data set. So the first thing we want to do is just make sure that our dates for this are looking like they're in date form, because we are going to need to do some subsetting based off of date. And if they kind of came through as characters, then that's going to be a problem for our subsetting. So let's just make sure everything is working there before we get going. And then we're going to create a then we're going to create a data set called this week. And this is going to look at this future data set just for the upcoming week's games. And so the way we're going to do that is we're going to filter date is greater than 2020 11 01 and 2020 11 08. I think that is the next week that I have in the data set. I am recording this on Saturday, so that makes it a little bit complicated because games are going on right now. So I've kind of had to not update the data set this week so I can record this. So I think that's the upcoming week from the perspective of the data set. All right, and so we're also going, so basically what we're doing here is to create this week, right? We need to basically have a data set with the same variables that were used to create the original model so that we can apply that model and get our forecast out. So since we're starting with this future data set, we made a bunch of manipulations that basically weren't carried over. We made a bunch of manipulations in the original L1 data set that weren't carried over to the future data set. So we kind of need to rebuild that structure. And so we're going to do that by starting with the select function and by selecting date, season, team, opponent, home, neutral location, and game ID. And so let's execute that. Hopefully we get some games in here. Oh, because I didn't put a condition here. So date, and that's going to be greater than or equal to. Okay, and so now we have 120 observations for our upcoming, quote-unquote, upcoming week, even though these games are actually being played sort of as I am writing this, or as I'm recording this, I should say. So now that we have that, what we're going to do is we need to bring in the ELO rating for the team and the opponent, and the way we're going to use that is through a left join statement. So let's copy out this week function. And what we're going to do is we're going to left join with the NCAA teams data set, and we're going to select team and ELO because we don't want to join whether it's FBS or not for this round. Okay. And so by is going to be equal to team equals team. Let's execute that, and then we can actually copy this out. Whoops, it looks like I'm missing a paren up here. Oh, it's actually because there's a space here. There shouldn't be a space there. And a paren. So let's actually abort that, and let's try and rerun this line. Okay, now it ran. Now let's copy this line. And now our team, we're going to change team and opponent. So now we're going to be joining the ELO based off of the opponent and not on the team. So that's going to load our opponent's ELO. And now let's just rename the names in this data set. So we're going to do names, NCAA this week, C, date, season, team, opponent, and if I can spell, I'll do home, neutral, location, let's do game, E, ELO, and op, ELO. Okay, so now if we take a look at this data set, I think we have everything we need except for the difference between these two ELOs. And then once we have that, we'll be able to forecast the future game spread and win probability. So let's add the ELO difference, because that's a pretty critical component to our model. So we'll do ELO difference equals ELO minus op ELO. We'll execute that. And now we can forecast next week's games. And let's just, let's copy out. So we already have the model built, so let's just copy out the spread prediction. And let's copy out the win probability. Or actually, I copied out the win probability. So now let's copy out the spread prediction. And we'll just replace some data here. So we'll replace the level 1 data set with the this week data set. And the new data is going to be this week. And then we should be able to execute these two lines. And now if we open up this week's data set, let's actually sort by the highest win probability, just so that we can see if it's sensible. Okay, and so the highest win probability for today is Ohio State versus Rutgers. So we have a basically a 99% chance. And actually this game might be either over or going on right now. So I might actually just Google it just to see how this is going in real time. So let's check out Ohio State Rutgers. Okay, so that's not until 7:30 tonight, but let's actually click on this, and actually let's go to ESPN and see if they show us the line on this. It's going to be this game. All right, so we have a 98.6 win probability, so that's pretty similar to our win probability. They have a spread. Okay, there's no spread here. I feel like usually there's spread down here. But anyway, we can see that this is a 98% win probability. So we're pretty much in line with what ESPN is forecasting as well, which is a pretty good start to our model. So that's it for this video. I hope you guys liked it. If you found it valuable, remember to subscribe. Also, if you're finding this stuff valuable, remember to follow me on Twitter, because if there are any updates to the data set, that's where I am going to be kind of blasting out those notices. And also, if you follow me in those two places, you'll be able to know when I'm making, when I'm releasing new data, so new NCAA data, and new data for other sports and other topics. Again, so I hope you guys liked it. Thanks for listening.